This is chapter P.6, Factoring, Day 2. In this section, we are going to focus on factoring polynomials with 4 terms and also polynomials that require a special factoring formula. So looking at this first example, we see that we have 4 terms in this polynomial. And over here, we have the process written down. And what we need to do is divide this polynomial down the middle by drawing a line after the second term, but before the operational symbol. And we are going to factor out the greatest common factor on both sides. So if I look at the first 2 terms and only look at the first 2 terms, I have 2x squared minus 10x. If I think about the greatest common factor there, my greatest common factor is 2x. So if I factor out 2x, I'm going to be left with x minus 5 on the inside. So over here, I'm going to do the same thing. I look at these 2 terms, and my greatest common factor is 3. So I'm going to put plus, because it's positive, 3, and then parentheses, x. When I factor out the 3, I get x and minus 5. So what you will notice is that we end up with the same thing in the parentheses here. And so once we find the greatest common factor and factor it out, we want to consider both sides of the line. And now we want to identify the greatest common factor when we are comparing the 2 sides of the line. And that's why it is important that the x minus 5 was the same thing in the parentheses here. Because between the left side and the right side, that is our greatest common factor. So I'm going to write that down, x minus 5. That's my factor. I'm going to factor that out. Well, when I factor that out, I'm going to ignore those or cancel them out and look at what I have left. I have a 2x plus 3, and that becomes my other factor. So x minus 5 and 2x plus 3 are the factors of this polynomial. Going on to this next example, we are using a factoring formula. So first of all, when I look at this, I'm going to identify that this is a binomial without a greatest common factor. So I can't factor out a greatest common factor. Since it's 2 terms, I want to ask myself, and I want to identify, is it one of the following types of problems? Do I have something squared minus something squared? Or do I have something cubed minus something cubed? Or do I have something cubed plus something cubed? Well, first of all, this is minus, so I know it's not the third one here. And if I look at my exponents on the variable, I have squares, not cubes. Okay, so therefore, I'm really looking at this as an x squared minus y squared. Maybe. Okay, I have to determine, are these really perfect square terms? So what that means is, can I take the square root of 16? X squared. So if I take the square root of 16x squared, I think about the square root of 16 is 4, and the square root of x squared is x. So yeah, I can. So what this is really telling me is that I have 4x squared is the same thing as having 16x squared. So the 4x, because 4 squared is 16 and x squared is x squared. Now same thing with the 25y squared. If I take the square root of 25y squared, I'm going to get the square root of 25 is 5. The square root of y squared is y. So I can rewrite 25y squared as 5y quantity squared. So now I have something squared minus something squared evident. And what I'm going to do is use the factoring formula. So x squared minus y squared is factored as x plus y and x minus y. So I could also think about this as a squared minus b squared equals a plus b times a minus b. Okay, same thing. And I can think about this as, well, my a is 4x. My b is 5y. So I'm just plugging in to the factoring formula the 4x and the 5y. So instead of a plus b, I get 4x plus 5y. And instead of a minus b, I'm going to have 4x minus 5y. And these are my factors for that polynomial. Some more factoring formulas. Here's another example. So if you think about the steps that we've talked about already, is it written in order? Yes. Do I have a greatest common factor? Well, if I look at 12 and I look at 27, I have a greatest common factor of 3. So if I factor out a 3, 12 divided by 3 is 4, and I have x squared. Minus 27 divided by 3 is 9. So now I still have two terms here, and I need to consider whether or not this is an x squared minus y squared, an x squared cubed minus y cubed, or x cubed plus y cubed. It's minus again, and we have x squared. So I'm going to go with the x squared minus y squared and make sure that works. So can I take the square root of 4y squared? Well, square root of 4 is 2, and square root of y squared is y. So the 4x squared is the same thing as, sorry, not x, y, but x. So let me write that over. So 2x quantity squared. And 9, the square root of 9 is 3. So that's like having minus 3 squared. Let me put this all in parentheses here, and let me fix the exponent right there, because that should say 2. Okay, so I've got my 3 out front, and now I have a squared, or x squared minus y squared. So again, x squared minus y squared is the same thing as having x plus y and x minus y. So whatever is squared goes in here for x and y. The first term is x, the second term is y. So I get my 2x plus my y, which is 3, and 2x minus 3. Okay? Because I have to think about what is being squared. So 2x is squared instead of the x here. So in place of x, I'm writing 2x. And then for my y, I have 3 squared. So in place of the y's, I'm plugging in 3. Okay? Now, let's look at this last one here. I have 8x cubed plus 27y to the 6th. Okay? Well, alphabetically, x comes before y, and that's the only x. So this is written in the proper order. And I have a greatest common factor here of, no, I don't. I don't have a greatest common factor. Um, so I have cube. I might have something like x cubed plus y cubed. So I need to check, can I take the cube root of 8x to the third? Cube root of 8 is 2. Cube root of x to the third is x. So that's the same thing as having 2x quantity to the third. Okay, now can I take the cube root of 27y to the sixth? The cube root of 27 is 3, and the cube root of y to the sixth, because y to the 6 thirds, remember the radical value is the denominator on the exponent, And 6 over 3 is 2, so y squared. So that's y squared. So my value that is being cubed here is 3y squared. And then I'm going to follow the factoring formula for x cubed plus y cubed. And the factoring formula for that is x plus y times x squared minus x times y plus y squared. Okay, so I'm just going to place this in, and anywhere I had an x, I'm going to plug in 2x, and anywhere I had a y in my formula, I'm going to plug in 3y squared. So thinking about this, I have x plus y, so I'm going to put 2x plus 3y squared. And then x squared is the 2x being squared minus x times y, so that's 2x times the 3y squared, and then plus the y value squared, so I'm taking that 3y squared and squaring that. So now let's clean this up. The first part here stays. Okay, so the first factor here stays the same, 2x plus 3y squared. And then 2x, sorry about the bell, 2x squared would be 4x squared because 2 squared and x squared. 2 times 3 is 6, and then I have x times y squared. And then 3 squared here is 9, and y squared squared would be y to the fourth. And there are my factors for that example. And that's it.